Welcome back. We are going to finish up our solving quadratics by using quadratic formula. A reminder that the quadratic formula requires your quadratic equation to be in standard form with all terms represented. Remember, standard form is ax squared plus bx plus c equals 0. We're using a, b, and c, the numerical values, not the variables. Okay, we don't use the x's, we only use the numbers when we're plugging it into the formula. And remember, make sure that you're super careful, especially with the negative b and then this b squared when you're plugging in values, because if your b value is negative, like let's say this was 3x squared minus 4x plus 7, then we would have a negative 4, and this would be a negative 4 squared. Those parentheses, remember, are important because they change your answer in the end if we don't have them. So let's take a look and see what this does. If I'm using quadratic formula for this first set, we have a is 2, b is negative 5, and c is 3. So we have negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now it's important again that your fraction bar is underneath that whole top. The negative 5 becomes a positive 5. Negative 5 squared is 25. 4 times 2 is 8. 8 times 3 is 24. So underneath the square root, we have 25 minus 24, which is 1. And on the bottom, we have 2 times 2 is 4. The square root of 1 is 1. And so we can do this math since I no longer have a radical here. We have 5 plus 1 divided by 4, which is 6/4, or 3/2 as one of our x values. That's our root and x-intercept 0 solution. And then the other math that we would do is the 5 minus 1 over 4, which is 4/4, or 1. So 3/2 and 1 are my two answers. For letter B, this is not equal to 0. I'll start with moving the 5 over. The opposite of a minus 5 is a plus 5. So we have x squared minus 6x plus 5 is equal to 0. I have standard form. It's equal to 0. There's a 1 in front of that x squared, so our a is 1, our b is negative 6, and our c is 5. Plugging that into the formula, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, a negative 6 is positive 6. Negative 6 squared here under the radical is 36, minus 4 times 1 times 5 is 20. 36 minus 20 is 16. The square root of 16 is 4. So we have 6 plus or minus 4 over 2. There's no square root there, so we can continue to do our math. 6 plus 4 divided by 2 is 10 over 2, or 5. And 6 minus 4 over 2 is 2 over 2, or 1. So the roots, zeros, x-intercept solutions of this example B are 5 and 1. Typically, when we have an answer that doesn't have a square root in it, that means that we could have solved this by factoring. That would be factorable. Now, the quadratic formula works to solve absolutely any quadratic that we have. So you would have a choice. Do you want to try factoring, or are you comfortable with quadratic formula? I'm going to talk about the discriminant. The discriminant is that value underneath the radical. So it's just the b squared minus 4ac, which you can see here. The discriminant tells us what kind of answers we'll have and how many. So if underneath the radical you have b squared minus 4ac is greater than 0, that means that's a positive number, and you will have 2 real solutions and 2 x-intercepts, because remember, our solutions are the x-intercepts, as you can see here. B squared minus 4ac is equal to 0, so we have the square root of 0. Remember, that only has one answer, and so there would be 1 real solution and 1 x-intercept. If the discriminant b squared minus 4ac is less than 0 or negative, then there are no real solutions and no x-intercepts. There's 2 types of questions that you'll get regarding the discriminant. The first one would be determine the number of real solutions. So it's not asking you for the answers, it just wants to know how many and what kind. Example C is in standard form and it's equal to 0. We have a 1 here for A, B is 8, C is negative 3. Because it just wants to know how many and what kind, then we're just doing b squared minus 4ac. We're finding the discriminant. Our b is 8 minus 4 times a is 1, and c is negative 3. This is 64 plus 12, which is 76. 76 is greater than 0, so there are 2 real solutions, x-intercepts. Example D is not equal to 0 and not in standard form. So we'll start with the opposite of adding 6x is subtracting 6x to move it to the other side. 9x squared minus 6x plus 1 is equal to 0. We have A, B, and C. B squared minus 4AC is 36 minus 36, which is 0. 0 equals 0, so that means there's 1 real solution or x-intercept. We don't know what it is. It's not necessarily 0, but we know that there's only going to be 1. Example E, we are adding 1 to the other side. 6x squared plus 2x plus 1 is equal to 0. We now have standard form, and it's equal to 0. A, B, C. 2 squared minus 4 times A times C. That's 4 minus 24, which is negative 20. Negative 20 is less than 0. That means there are no real solutions or x-intercepts. The other type of questions that will be asked is determine the number of x-intercepts. Now, the number of x-intercepts and the number of solutions means the same thing. So we're still using the discriminant and finding just b squared minus 4ac to know if it's greater than 0, equal to 0, or less than 0. We have A, B, and C because this is equal to y or 0. And this is in standard form. B squared minus 4ac gives us 9 minus 72, which is negative 63. Negative 63 is less than 0, so there are no real solutions or no x-intercepts. Example G, A, B, C. Negative 4 squared minus 4 times 2 times negative 3. It's positive 16 plus 18. Oh, sorry, that's wrong. It's not 18. That's 8 times, that's 24. 16 plus 24 is 40. 40 is greater than 0, so there would be 2 x-intercepts or solutions. That's it for Chapter 9. Thank you so much again for joining me. Have a great rest of your day.